My dear students, good morning to all. In the previous classes we have discussed about the basic concepts of physics. So many of you have asked me to define once again, that is the types of motion. Okay, let us define once again. The first type of motion is the linear motion, the type of motion in which the object or body moves along a straight line is the linear motion. Then circular motion, a type of motion in which the object moves along a circular path, that is the circular motion. Then the third one is the oscillatory motion. See, to and fro motion of the object, to and fro motion of the object is considered as oscillatory motion. The best example for these two oscillatory motion is the motion of pendulum in a wall clock. Motion of pendulum in a wall clock is the best example for what? To and fro motion, that is the oscillatory motion. Then second suitable example is a swing. While you playing a swing, you know that swing is moving from that side to this side. So that is called to and fro motion of the object. That is called oscillatory motion. Then one more motion we have defined, that is the uniform motion. Uniform motion means whenever the object travels equal distances in equal intervals of time, then the object is said to be moving in a uniform motion. For example, let us take the 10 kilometer distance. 10 kilometer distance. Let us mark them as 5 different parts which are equal in magnitude, 1, 2, 3, 4, then 5. If 2 kilometers is covered in 5 seconds or 15 seconds, another 2 kilometers should cover in 15 seconds, another 2 kilometers should cover in 15 seconds, another 2 kilometers cover in 15 seconds, another 2 kilometers cover in 15 seconds. So in such a way, whenever the object covers equal distances in equal intervals of time, then that type of motion is said to be what that we call as the uniform motion. So let us begin today. The first chapter of your academic syllabus is force and pressure. Force and pressure. See, in our daily life, we come across certain examples. For example, a running a horse, or a walking man, flowing water, then sitting and kicking a ball. In all these cases, in which cases? For example, a man walking. A man walking means he has to push the ground from his toes to move forward. Then a sitting person, when he try to stand up, what he has to do? He has to push his hands to the ground, then slowly his body will rises up. So what happens in both the cases? Do you think about that? No, never. Because this whatever that concept, that rising the man or that which helps for the walking is nothing but that is the force. Due to a force we can move or we can stand up easily. So how we can define the force? How we can define the force? See, in simple way, pushing or pulling the object. The pushing or pulling is considered as force. But scientifically, this is not a suitable answer for defining the force, as we consider force as a physics related term. Then how we can define the force? See, it is an external agent. An external agent which tends the body to move either forward or backward, in which direction it acts. See, external agent when which tends the body to move either forward or backward, in which direction it acts. For example, here is one object. Suppose if you want to move this object towards this, we have to apply the force here. When there is application of force, this object moves to these places. So, in which direction it acts? It is acting in this direction. What I am showing. So, suppose if the force acts in this direction, the object will be in this place. So, an external agent, force is an external agent which tends the body to move either forward or backward, in which direction it acts. So, it is the effects of pushing or pulling. We can define force as it is the effect of pushing or pulling. It is nothing but a force. It is denoted by capital F. It is denoted by capital F. In some cases, it is also denoted by small f. So now, while we define the force, let us indicate by capital F. Then, what is the SI unit of force? You know, there are system of international. There is, for every scientific terms, there is a SI unit. So the SI unit of force is Newton. SI unit of force is Newton. Don't write N as a capital because Newton is the name of the scientist. Don't write. But symbolically, if you write the SI unit of Newton, you can use the capital N. So it has named up in the memory of Newton, a great scientist, Newton. SI unit of force is Newton. Then we have to mention which physical quantity it belongs to. We know there are two physical quantities. Two physical quantities. First one is scalar, second one is vector. See, vector quantity means the physical quantity having only magnitude but no direction. Vector quantity is the physical quantity having both, that is direction and magnitude. So the force is a vector quantity. Force is a vector quantity. What quantity it is? Force is a vector quantity. Why force is a vector quantity? Because it has both magnitude and direction. Since it is having both magnitude and direction, so force is a vector quantity. Now, how force is measured? Force is measured by the product of mass and acceleration produced. acceleration produced. So we can represent mathematically that F equals to m into a, that is equals to F equals to ma is the measurement of force. So F equals to ma, the SI unit of force is Newton. So whenever we calculate the force, we have to mention its unit as Newton. So force is measured by the product of mass and the acceleration. Then is the force is produces when only one object interact each other? No, never. Whenever if there is a existence of force, there must be interaction of two objects. Interaction of two objects. No force is produced. No force is produced if there is no interaction of two objects. That means no longer we get the force if there is interaction of the objects. So the existence of force. So existence of force depend on the interaction of two different objects. Two different or same objects. Existence of force depend on the interaction of two different objects. For example, the interaction. Suppose if you want to walk, there are two types of forces acting on your body. When we push the ground by the toes, there will be two opposing forces acting. That is the ground force. Then there is a toes force. Whenever they both act, whenever both the forces interact, there will be motion of the object. So if you want to have the motion, there should be two forces acting on that particular object. So now let us move to the what are the different types of forces. You know, the main force is the gravitational force. The main force is the gravitational force. Gravitational force. Then another force, that is the magnetic force. That is the magnetic force. Then electrostatic force. Electrostatic force. Then nuclear force. The nuclear force. We can classify the nuclear force as strong nuclear and weak nuclear forces. As strong and weak nuclear forces. Okay? These are the major types of forces. Gravitational force, magnetic force, electrostatic force, nuclear forces, strong and weak nuclear forces. So many different types of forces are there. In that topic, in this topic, whenever we move to the higher classes, we learn about these kind of forces. Now let us move to the what are the effects of forces. See, whenever force is applied on any object, there will be change of position of the object, in which direction it is acting. For example, I have shown you one diagram. The force is acting in this direction. There will be change of position object to this one. For example, say for example A to B. The object is going to B due to the direction of force in this way. Then this one is C. Then the force is applied here. The object will be at C. The direction is in this side. So there will be always the change of position of an object due to the applied force, in which direction usually the force is acting. Then the simple effect is there will be a change in the shape of the object, there will be a change in the direction of motion of an object, there will be increase in the acceleration, there will be a decrease in the acceleration, what we call as retardation. Then there will be the change in shape of the object. so many effect of forces are there with respect to this application of the force. So, tomorrow you don't write anything. I will give the notes related to force and its definition, its assignments, and related problems in the next forthcoming classes and the forthcoming classes. Then I will give notes related to the effects of force. So, boys and my dear students, be attentive while teaching the topics like force and pressure, because very important topic these two. So tomorrow we shall continue the next topic after providing the related notes to you. Thank you very much.